All right, so today we're going to talk about triangle inequalities just within a single triangle. Well, we won't do, there's another topic that I don't think we're going to get to this year, where you can look at two different triangles and do triangle inequalities. But this is things that are not equal within a single triangle. So in this triangle QRS, which side appears to be the longest? Yeah, it certainly looks like QS, right? Let's write blue so it shows up a little better. And which angle appears to be the largest of the three angles? Angle R. And which side appears to be the shortest side? RS. This one's a little harder to tell, but which angle appears to be the smaller angle?
Q.
Angle Q. Angle Q is actually a little smaller than angle S. And your eye deceives you because these are longer into thinking sometimes that S is bigger, but if we just look at this part, you're like, oh, those are closer together than over here, but not by a ton. Okay, like, okay, so seriously? You're gonna do that to me, huh? Okay, we'll do it the old-fashioned way. So notice, here is the longest side. You don't need to write this necessarily. And this is the largest angle. Right? They are across the triangle from one another. And then this was the shortest side. And this is the smallest angle. And those are across from each other also. Right? Okay. So actually this goes back to, if we have an isosceles triangle, again, you don't need to draw this. If I have an isosceles triangle where those two are the congruent sides, then which two angles are congruent? A and C. Since these two are equal to each other, these two angles are equal to each other. And where are those angles? They're across the triangle from those two sides. You see how that ties all together? So in this triangle, the smallest side is AC, and is it pretty clear that the smallest angle is angle B? Okay, so I will warn you of something on this unit. Sometimes there will not be drawn to scale on purpose. So you can't just look at it and go, well, that's the biggest side, because it looks like it's the biggest side. Okay? So, our theorem is, in a triangle, notice it says in a triangle. This does not work if you're looking at two triangles at the same time. You have to only look at one triangle at a time, and I'll point that out to you in a problem in just a moment. Okay? In a triangle, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. Okay? All right, let's start with the insanely easy question. And notice, this is not at all drawn to scale, is it? It looks equilateral, and that's on purpose, so that you can't just look at it and go, well, I'm going to base this on what it looks like. So it says, write the angles in order from least to greatest. It has happened far too often, even in the honors class, that some student will breeze through the instructions and not read whether it asks for greatest to least or least to greatest and do them all backwards. And it's sad, but the points still come off. Okay? Don't let that happen to you. All right. So we want the smallest angle. Well, where is the shortest side? BG. So the smallest angle is angle I. What is the next biggest side? BI. So the next biggest angle would be G. Across the triangle from it. And the biggest side is 19, IG, so the biggest angle is angle B. They really don't get much easier than that. Okay, so let's do one that requires you to do a little more work. Here we're going to write the sides in order from least to greatest. Okay, but they didn't give us any of the angle measures.
180.
What about 180?
All three angles add up to be 180.
Okay, so all three angles are going to add up to be equal to 180. So I should be able to figure out which is the biggest angle and which is the smallest angle. So let's see, 3x minus 7 plus 2x plus 9 plus 5x minus 26 is equal to 180. So that's 10x minus 24 is equal to 180. Make sure I did the arithmetic right there. I think that's right. Yes? So add 24 to both sides and we get 10x is equal to 204. So x is 20.4. So now we need to figure out, well, what's the biggest angle and what's the smallest angle? Is there any way to tell just by looking at these? Nope. So let's see. The measure of angle A is 2 times 20.4 plus 9. See, that's 40.8 plus 9 is 49.8. The measure of angle C would be 3 times 20.4 minus 7. Let's see, that's 61.2 minus 7 is 54.2. And then the measure of angle T would be 5 times 20.4 minus 26. Let's see, that's 102 minus 26 is 76. How can I check this? Yeah. Yeah, add them up, see if they're equal to 180. So let's see, 0.8, 0.2, that's 1, that would be 10. Plus 4 plus 6 is another 10, makes 20. That's 60. Plus 5 is 110, plus 70, 180. Okay. I wouldn't take the time to write it all out. I would just check it in your head real quick to make sure. So the smallest angle is angle A. So where is the shortest side? CT. Then the next bigger angle was C. So the next bigger side would be opposite that is AT. And the biggest angle was angle T. So the largest side is CA. Okay, everybody good with that? Okay, page 2. Here's what I was talking about when I said you can only look at one triangle. You'll get problems like this where you have two triangles that are stuck together. And you're like, well, what am I supposed to do with that? Well, Do one triangle at a time and see if you can figure something out. So let's do the triangle on the left. See, 23 plus 37 is 60. So what's this angle? 120. Very badly not drawn to scale. Okay, again, that's on purpose so you can't just look at it and go, oh, that's the biggest side. So could I put these three sides in order on the left? What's the shortest side? YA is the shortest side, right?
What? Y'all drew that so.
I told you that just seconds ago. This is badly not drawn to scale. What's the next biggest side? KA. What's the biggest side on this side? KY. All right, now let's do this triangle. Let's see, 90 plus 48 is 138. From 180 is 42. So what's the shortest side? AR. Then what? YR. And what's the biggest side? YA. Now, do you notice that this list ends with YA and this list starts with YA? So we can just stick them together. AR is shorter than YR, which is shorter than YA, which according to this list is shorter than KA, which is shorter than KY. So when you're doing this, do one triangle at a time. Don't try to do both at once. You'll get the wrong answer. Okay? All right, let's move on. The triangle inequality theorem. You actually learned this in 7th grade. Yes, I know you've slept since then, so you probably have forgotten it. But basically what it says is the sum of any two sides of a triangle is greater than the third side. And you're like, well, yeah, it has to be, right? And I think that the example that we used in 7th grade, there was like your house was here and the store was here, and I think there was a playground over here. And I said, what's the fastest way to get from your house to the store? Yeah. If you went to the playground first, the sum of these two distances is longer than this one, right? No matter what. That's it. That is the triangle inequality theorem. The sum of any two sides has to be greater than the third side. So, and we did some problems like this also. Tell whether a triangle can have sides with the given lengths. Can you have a triangle that has sides of length 7, 4, and 6? Yeah, and the thing to check is the two short sides added together. 4 plus 6, is that greater than 7? Yes. So the answer to this question is yes. What about the next one? Is 3 plus 5 greater than 8? Nope. So this does not make a triangle. If you tried to make a triangle out of those, what would happen? Yeah. If you had the side that was 8, say horizontally, so let's say that this is 8. The only way to attach the 3 to this end and the 5 to the other end and make them touch would be to have it like this, or that's 5 and that's 3. Not exactly a triangle, is it? Okay, let's take a look at this last one. If we add 1.6 plus 4.7, is that greater than 9? No. Yeah, that's not even 7. So that doesn't make a triangle. On that one, it would be kind of like this. They would all be laying down and they'd be like, I can't reach. Okay? All right. Let's take this a step further. So the questions that we just did, we did those in 7th grade. Now we're going to take it up a step. So it says the lengths of two sides of a triangle are given. Find the range of possible lengths for the third side. Okay? So one side is 8, the other side is 11. There's got to be 3 sides, right? So it's got to be, can it be 3? No. Well, what about 3.1? Right. It just needs to be bigger than 3, right? Is there any limit to how big it can be? Really? If the third side was 75, would this make a triangle?
It needs to be more than 3 and less than 19.
Where'd you get 19 from?
8 plus 11.
Yeah. It's got to be in between 3 and 19. Can it be equal to 3? No. But if it's even a little bit bigger than 3, you would have a very skinny triangle. And it could be close to 19, but it can't be equal to 19, because if it did, you would have a flat triangle.
How skinny of a triangle would it be?
If you had, like, what?
8, 11, and 3.01.
It'd be really skinny. It would be almost flat. Right, because if you put the 11 on bottom, and then you had, what was it, an 8 and a 3.1, it would be about like this.
It looks like a box.
A what?
A box. Like a flat box. And then like here's the box.
Oh, I see what you're saying. Okay. All right, so what about if the two sides you were given are 5 and 19?
Less than 14. I mean greater than 14.
All right, so it's got to be more than 14.
And less than.
But less than 24, exactly right. Somewhere between 14 and 24, but not equal to 14 and not equal to 24. Anywhere in between, though, it's going to make a triangle, even if it is a really skinny one. Two more. So for this one, fractions, everybody's favorite. I love Colton's I'm not impressed face.
No, that's too much. It's too much work.
Oh, come on. What do we need to do with these two numbers?
Subtract.
We need to subtract them. So let's see, 7 and 5/6 minus 4 and 2/3. That's some good 6th grade math there. I would make that 4 and 4/6. I would definitely not make it an improper fraction. A lot of people default to that, and I'm like, ugh, it's just horrible. So 7 and 5/6 minus 4 and 4/6 is 3 and 1/6. By the way, just a real quick note, what if it had been, everybody watch this, what if it had been 7 and 4/6 minus 4 and 5/6?
Make it into 6 and 10. You take on the
Yeah, that's what I would do. Make this 6 and 10/6. Very good, Marion.
Wow, 6th grade math.
Well, it's again, I have a lot of students who at this point would go, "Oh, you have to make it an improper fraction." I'm like, why would you do that? And because they don't really understand borrowing. We borrow 1 from 6, and it's 6/6. They don't really get that.
Not putting it anywhere, it's like taking it away and just putting it somewhere else.
Right. All right. So it's got to be bigger than 3 and 1/6, and now we need to add them together. See, that's 7 and 5/6 plus 4 and 4/6 is 11 and 9/6, which is equal to what?
12 and a half.
Yeah, it's 12 and 3/6, which is 12 and a half. So 3 and 1/6 is less than the third side, which in turn is less than 12 and a half. All right, what if the two sides are 7 and 7?
Between
0 and 14.
Yeah. The third side's got to be between 0 and 14. All right, because if you had two sides that were 7, couldn't you make a really, really, really skinny triangle?
And make it like 0.01.
Like that?
Yeah.
Or that's 7 and that's 7, and if those are both 7, this looks like about 0.2. As long as it's more than 0, you would still have a triangle.
Looks like a face.
a base.
It kind of does. Or you put an
unicorn.
oval around it and it's a face.
Yeah.
And like the 0.2 are the teeth and
Yeah.
the 7s are the
It's
eye.
a goat.
Of
Oh yeah, like a mountain goat.
Yeah.
Make a really, really skinny oval.
I love the creativity.
All right. Any other questions?
No,
All right.